So our example here is h of theta is equal to negative 1/2 times the tangent of theta. So what we'll do is we'll just get a general idea of what the graph looks like. So we'll go ahead and plot this guy out for a couple of cycles. So I'm going to label my asymptotes here. The first asymptote is going to occur at pi over 2. The second one is going to occur at 3 pi over 2. The reason for this, if you think about so just a refresher here for you, is if you think about the way the unit circle works, okay, the tangent value is, well, there's a couple ways to think about it. I'm going to think about it as the slope of the line coming out to the angle, and the slope here, anytime you're vertically, either up or down this way, so here at pi over 2 and here at 3 pi over 2, you're going to have a vertical tangent line. And once your line is vertical here and here, it's going to be undefined. So we're going to have undefined values. The other way to think about this is it's sine over cosine, and cosine is 0 at those values. So again, at negative pi over 2, there will be a dashed line. So, excuse me, you want to go ahead, negative 3 pi over 2. You want to go ahead and put those guys in. So this guy's at 0, so here is pi, here is 2 pi. This is 0, this is negative pi, so on and so forth. So our the original function, the parent graph, cuts through the origin, comes up like this, and down like this. Again, over here at pi, it's at a value of 0, so it's going to head up like this, and back down like this. I put a little, I guess I'll clean that up. There we go. So again, up and back down. So over here, down, over here. If I can get it to, it's not wanting to draw that close to the edge. That's what it looks like. So the yellow is the original tangent function. Now we can do the negative or the 1/2, whichever order you want to go in first. So what's going to happen is I'll do the negative. So what I'm going to graph here is a different function. I'll say g of theta, which is equal to negative tangent theta. So negative, this is a reflection of flip on the x-axis. That's what that negative stands for. So you got to remember back to your 310 course what that value does. So what's going to happen is this guy that was normally up here, it's going to come down like this. A point that was already at 0 is going to stay there. Well, a point that already had a height of 0. So the green line is this negative tangent theta. So what I'm going to do is I'm going to go back and I'm going to erase the yellow line as best I can, so that you can really see the green line here. Okay, there it is. So that is negative tangent theta. And I went ahead and flipped it. Now the last piece that we have to put in here, and we'll do that in orange. Actually, let's do it in blue. A light blue is to put the 1/2 in there. So this is h of theta is equal to negative 1/2 times the tangent theta. So what I need to do is take negative tangent theta and multiply it by 1/2. Since it's on the outside, meaning it's happened after the function occurs to the theta value, this is going to be a vertical compression meaning every value, every y value, write that down, all y values are 1/2 their height. So usually it's easy because we can say, okay, that's amplitude. Now here, there's no amplitude because there's no difference between the top and the bottom value because they go to infinity. But the half still impacts that stretch. So everything's 1/2 of its original height. So these guys are all going to stay the same because they have a height of 0. That one's hard to circle in there. However, everything's going to drop 1/2 of its height. So this guy's going to come down. Okay. These guys are all going to come down. And it's going to look... This guy's half the height, 1/2 of its height, 1/2 of its height. So it's going to come up like this and down like this. Now it still stretches all the way up, it still stretches all the way down. So there's nothing different about that. It's just that everything's at 1/2 of its original height. So these blue lines represent the final function. It doesn't look like much for that compression. Now let me show you, let's use Maple here, and I can show you the difference between all three graphs. Okay, so right now what I'm going to do is I'm going to plot the original function, which is tangent. Let's go from negative, let's just do from 0 to 2 pi. Okay. And our y value is from -5 to 5. And now the first one, the original one here, I'm going to graph in blue. Now I don't like those vertical lines, so let's get rid of them. Okay, and let me actually go back just a little bit here as well. Let's go to like -pi. There it is. That's the original graph. And if you notice, oops, I erased it, but that was the original graph that I had done here in yellow. So if you want to rewind, you can go back and look at that one in yellow. Now what I'm going to do is I'm going to graph that negative tangent of theta. Okay, and I'm going to make that one, let's make that one, oh, what color was I using before? I used a light blue, so let's, whoops, I gotta go back here. So I don't know, well, let's just make, let's make the original yellow, because that's what it was. Okay, so here. Make the original yellow, and now the next one blue. So the original graph is the yellow one coming through here. Its reflection is the blue graph. Okay. Now let's add to it. Let's add to it one more graph. Let's add the 1/2, -1/2 tangent. And I think the last one I used on that one, let's go back and look just to make sure. Oh, actually I switched these. It was green and then blue. Well, it doesn't matter. You guys understand. You get the idea. So let's use red. Why not? So the red line, and let me take off the original. So what you can tell is the blue line is negative tangent theta. It's this guy right here. But the red line is 1/2 the height. So you can see how it just kind of squishes a little bit closer to the axis. Basically, everything's pulling 1/2 its length towards the axis. So if it was down here at a height of -1, it's now at a -1/2. If it was at a height of negative, let's say -3, it's at a height of -1.5, so on and so forth. Okay, and that basically describes how to go ahead and graph that.